Okay. So and this one was really similar to the sample one they gave us. All right, so it says on the initial date of sales at time 0 for a new video game, there were 40,000 units of that game sold that day. 91 days later, so T equals 91, there were 76,000 units of the game sold that day. The number of units of the video game sold on a given day can be modeled by the function g, given by g of t equals a plus b ln of t plus 1. All right, where g is the number of units sold in thousands on day 1 since the initial day of sales. And so part A, question 1, okay, is always going to ask you to put in some values that you have to write two equations, okay? So we're going to put in what they told me. So they gave me the ordered pair 0, 40 and the ordered pair 91, 76, okay? So if I put that in to that G equation that they gave me, which was right here, okay, my first equation, 40, would equal A plus B ln of 0 plus 1. And you can leave it like that. You don't have to simplify. And the second one, 76, equals A plus B ln of 91 plus 1. Okay? And so we could just leave them like that, which is nice. Right. And then part 2 is going to always ask you to find those values for those constants that are still left. Right? Be it exponential. I think it was exponential on your practice exam we did yesterday, wasn't it? Okay. Or logarithmic. So if we simplify just a little bit, we know that 0 plus 1 would give me just the natural log of 1. And because this is calculator active, we could try natural log of 1, which is just 0. So we know that A is going to equal 40 because that bad boy is equal to 0. So we get our A value of 40. Right. Then to find B, we're going to use that second equation. Right? And I'm going to plug in the A value that I know. So I have 76 equals 40 plus B natural log of 92. And we're just going to solve for B. So I'd move the 40 over. I have 36 equals B natural log of 92. And then we're going to divide by natural log of 92. So B is going to equal 36 divided by the natural log of 92. And we'd use our calculator. Right. And again, how many decimal places are we taking? 3. So I get 7.961. Right. So that's the first part, part A. 2 points, okay, that we could get. Yeah, I agree. What are you doing?
I'm hanging a couple flags up.
Oh, I was like, oh, are you throwing stuff or what?
What's those snacks we eat? Put a snack in your hand.
Oh, that's funny. Okay, so now let's look at part B. And then on part B, the first one, it says use the given data to find the average rate of change of the number of units the video game sold in thousands per day from 0 to 91. Here's something that's important right here. They just gave you your units, okay, for your rate of change right there in the statement. So when it asks for what units to be put, it's right there in the sentence. They gave it to me. Express it as a decimal and show your computation. So if we're going to do average rate of change, remember average rate of change is just what? Slope, okay? So we're going to do G at 91 minus G at 0 over 91 minus 0. And they gave me those values when we started, okay? G at 91 was 76 minus 40 over 91. It's just slope, okay? And again, we're going to use our calculator to do that. OMG. That's not him. He's got a key. What kind of paper? Yes. All right. So this is where we have to put the units. This is where you have to be careful because it says thousands of units per day. So in 1,000 units per day, right? So be sure you put that on there because they give it to you. Okay.
Thank you.
You're welcome. All right. Now, this is where it gets a little interesting. This one varies a little bit from the last example that we saw, all right? On part 2, it says to use the average rate of change found in part 1 to estimate the number of units on day 50 and show the work that leads to your answer, okay? What this is asking me to do is to write the equation of a line, right? It's asking me to write the equation of the line. This rate of change we just found is going to be the same thing as my slope, okay? And so to write the equation of a line, what are the two things that we need? Okay, we need at least a point of some kind and the slope. Did they happen to give me the y-intercept? Yeah, they did, all right, which is nice. So my approximation could be y equals my slope, 0.396. They used a t, right? Or we could use an x. Plus, and what was that value when time was 0? It was 40. Okay, and so that works. So this is what we're going to use to approximate. Now, the approximation they ask me to make is at t equals, what, 50? Yes, at 50, right? So we're going to approximate it. Y at 50 is going to be 0.396 times 50 plus 40. And this is giving me the number of units, so 1,000 units. So that was part 2, okay? Y equals 0.396x plus 40. So we use that average rate of change to be my slope because we calculated it like slope. And we chose the y-intercept, or we could have used the other point and done point slope if we wanted, but they gave me the y-intercept, which was nice. So we just tacked it on at the end, okay? It's like writing the equation of an arithmetic sequence, all right, all that good stuff, okay? So a lot of work to get there. Okay, but you just get a point for that final answer in the end. Show your computation, okay? If you thought through it a different way, that works as well, okay? So like if you just wanted to apply the rate of change over and over and over from time 0 to time 50, you can do that, okay? Because it's just going to change by that amount every time. You could do that as well, okay? So just show your work that you're using to get there. And then on part 3 of that section, it says, let A sub t represent the estimate of the number of units of the video game sold in thousands using the average rate of change found in part 1. For A of 50, found in part 2, it can be shown that the approximation is less than the actual value, okay? That's what that says. A of 50 is less than G of 50. That means my approximation is smaller than the actual value. Explain why, in general, that the approximations will be smaller than the actual value everywhere between 0 and 91. Okay, why would that be true? What is it we look at to see if my approximation is over or under? We could look at a residual. What else could we do? What else tells me about over and under approximations? Concavity. Okay, concavity tells us about under and over approximations, right? So if I could figure out the concavity of my function, then I would know if my estimate was over or under, okay? So remember, if something's concave down, all right, my approximation would be over. If it's concave up, my approximation would be under. It's telling me here that the approximation is less than the actual function. So what kind of concavity should I get? Up. Okay, I should get concave up. So let's look and see if that's true. All right, let's look and see if that's true. Okay, so let's look at our equation. What was our equation for G that we finally found at some point up here? Did they give me one? They did not. Okay, but let's look at what's happening with G. All right. So we know just in general, all right, G at 0 would be like right here. All right, it's at 91. Okay. And they told me, no, G at 0 is at 46, sorry. And then G at 91, so out here, it's 76. So I got 40 and I got 76, all right? Let's see, what else did they tell me? Let's see. All right, oh yeah, we did find the equation. It was 40 plus 7.96, okay? So it's a natural log approximation, a natural log graph. What do natural log graphs look like? Yeah, what do they look like? I don't know. We got to know. What does an ln graph look like? What does an exponential graph look like? Yep, it's either growing or it's decaying, right? What changes when we do LNs or when we do logarithmic graphs? They get a vertical asymptote, all right? So they're either doing something like that or they're doing something like that, okay? So based on how this one looks, what kind of concavity do we have? It's concave down. Okay, it's concave down. Okay, now take a look at your average rate of change because we talked about the average rate of change between those 2 points. That's what part 2 is. So this one's a little bit different than what we normally do.
Sorry, so it talked about an approximation of less than the original?
That's where I'm getting. Okay, it's talking about the approximation because it came from the slope between those 2 points. That was the line we just wrote. Okay, this is what we wrote in part 2. All right, we didn't write a tangent slope. We wrote, if they had me pick, say, at t equals something else, 50, let's say, okay, my line would have been up at the top, okay? But they had me write the equation between the endpoints, and that's why this one's tricky, right? Where is that line with respect to the graph? Above it or below it? Where's the line with respect to the curve? It's below it, okay? It's below. So even though it's concave down, because we use the secant, okay, or because we did the approximation is between the endpoints. Okay, so we would say G of t is concave down, and because the approximation line is between the endpoints, then A of t is less than G of t on the entire interval. Okay, now that's where it's different, right? Because typically we have under and over approximations based on just concavity because we're touching the graph, but we weren't. We went between the endpoints, and that's what was different and tricky about this question. Okay, you want to know what the average global score was on that point? Like 0.4. Okay, most people didn't get it. All right, and that's okay. All right, it's okay. But if you know you're thinking about concavity, you're going to be one step closer, right, to getting that point. So that's what I like to show you. Question 2 is always more difficult. There will always be an average rate of change part on it, though. All right, so at least get that part. All right, there will always be a plug 2 points in and get a system. We can get that point. Okay, so if we could get half the points, that's putting us in a good spot for that question. You see what I'm saying? All right, you don't have to make a perfect score. And some of you did get perfect scores on some of the questions this time. All right, full 6 points. So, all right, I've got your results for you to see here in just a second. Okay? Not excited. It's okay. All right. So that was everything about questions 1 and 2. Okay, switch your packets. Let's go look at questions 3 and 4. Or did I do part C? No. Oh, sorry, I was just kidding. I lied. There's one more part. Y'all thought I forgot, didn't you? I did. Okay. Are y'all going to fight? Okay. Let's see. On part C, it said the makers of the video game reported that daily sales decreased after t equals 91. Explain why the error in model G increases after t equals 91. Oh, that's weird. Okay. Well, let's think about it. All right, so we know our graph looks something like this. All right, we know it's concave down. 91. Okay, so we know the graph of G of t is increasing. Okay, but it's also concave down, so how's it increasing? At an increasing or a decreasing rate? At a decreasing rate. Okay. So the daily sales would increase each day. So that would explain why the error in the model G increases. Oh, okay, what? Would increase each day. Right? So all right, hold on. I'll say that right. Let's do that. We know it's increasing at a decreasing rate. Okay, that I know. Decreased each day. Okay, so what would happen to the difference between what they're telling me has happened and based on my model? Because they're telling me it's decreasing, but we know just by looking at the graph, it's going to do what? Continue to increase. All right. And so what would happen to the difference between those two things? Right? They say the graph does something like that, but we know it doesn't. Right? So what's going to happen to the difference between those two things? It's going to get bigger every time. Okay? So because G of T is increasing at a decreasing rate, the difference between the actual sales and the predicted sales would increase. All right, that's what it is. That took me a minute. That's a tough one right there, okay? They're always going to ask you something weird in terms of interpretation. Spend a minute. I mean, that's one of those parts that if I have time, I go back to after I've done everything else. You know what I'm saying? And I try to think through what's really happening in that situation. I know the graph does this. They say the graph does this. All right, if I were to sketch that, what would it look like? What would the difference be? Put that phone away. Okay. All right, so let's switch packets and let's look at packet 3 and 4 and let's talk about those two questions, okay? Because we love to hate question 3. We either get it or we don't. There's really not a lot of in between on that bad boy. All right, when it comes to that periodic graph. Oh no, you okay? Okay. All right, let me export this and I'll switch over. Okay, got it. Oh, just kidding. All right, let's open that next one. All right. All right, so let's talk for a second about questions 3 and 4. Okay. The nice thing about it again is it's very consistent about what is that looks like my brain right now. Okay. Scored out of 6 points. These are non-calculator. Okay. Now I love some of y'all. But if you think I didn't notice yesterday that one of your answers was 3.746 on a non-calculator question, what did that mean? You picked up a calculator. Okay, that's why you'll be required to put it away before you get to these questions so you won't be tempted. Okay, you just weren't paying attention. I don't think it was malicious. I think you just weren't paying attention. Okay, you know, you're not going to get that option on Tuesday. But I got tickled when I was grading them. I'm like, oh my Lord. Okay. Some of y'all did, like I could see your long division where you try to take a fraction and make it a decimal. Don't do that. Leave it a fraction, okay? Because if you get that arithmetic wrong, you'll lose the point. So don't do that, all right? If it's a non-calculator and you get an improper fraction, leave that bad boy, okay? It's perfectly fine. All right, so this is the periodic one. It's always something presented in real-world context. It is all from Unit 3. It's that sinusoidal function, okay? The stem is going to be a paragraph describing a phenomenon, OMG, okay? It's going to ask you for information about the amplitude, the period, the vertical shift, the phase shift, may include a reflection so that some values are negative. You know, it's going to be tough, all right? I'm just going to be honest with you. Part A will always be identifying the coordinates for the 5 points. It will be 2 points. You get 1 point for getting all the x coordinates correct. You get 1 point for getting all the y coordinates correct, okay? So you can miss the x coordinates and get the y's. And vice versa, you can get the x's and miss the y's, okay? But if in the process you miss 1 x, you don't get the point of the 5, okay? So just as a heads up for that when scoring it. Part B, you have to find the equations, so A, B, C, and D. This is the weird part. You get a point for getting A and D correct, and a point for getting B and C correct, all right? So if you get A and C, you get no points because they're not connected, okay? That's how it works, right? It's not half a point for everything, all right? They lump A and D together because that's amplitude and midline, all right? And then they lump period and phase shift together, all right? So just know that. And that's frustrating. Some of you will get that back and be like, oh, I got A and C, right? It's just one of those things. And then part D will be that interpretation. So be careful with that one because a lot of you still got that one correct where it's the multiple choice, what's it doing based on concavity. So yay, all right? You could miss everything else and get that point, which is nice because you're looking at a separate graph. And then talking about something about the interval itself, what it's happening on, okay? So question 4 will always be symbolic manipulation. We will be solving equations. We will do trig identities, okay? And you're just going to have to know it all right? They could pick any function they want to be there. Trig, exponential, logarithmic, inverses, that's what it is. Okay, I'm just going to change the page. All right. And then it gives you the breakdown for the points for question 4. Okay, they'll either ask you in one part, because it'll have 2 parts, 1 and 2. For part A, it'll ask you to rewrite or solve in one or the other. Could involve identities, definitions, using inverses, all your things about trig. Same thing with part 2, all right? It'll have specific directions using properties, identities, and then the last part is always the most difficult part, okay? And it'll be something that requires us to use something about inputs and outputs. All right, domain and range. So here we go. Let's look at this one. Okay, let's walk through it. Here we got a fan. Blades of an electric fan rotate in a clockwise direction and complete 5 rotations every second. Okay, so I get, helps if you got a pin there, Miss Moore. 5 rotations in 1 second. So to do 1 rotation, what would it take? Yep, 1/5 of a second, which is 0.2, okay? You could leave it 1/5 if you wanted to, or you could make it 0.2, either one, okay? So every 1/5, okay, we're going to get, which is nice because I got 5 points. That's sweet, all right? They made it something we could do nicely, all right? Here we go. Let's see. Point B is at the tip of the fan blade is located directly above the center at t equals 0. Okay. So at time 0, all right, my fan blade is up there. Point 6 or point B is 6 inches from the center of the fan. So what's my radius? It's 6. And the center of the fan is 20 inches above a level table. Okay. So from the center to the table is 20, okay? So at point B, wherever that happens to be, all right, I'm at 0, 26, okay? So what I want to do is I want to talk about what happens. So I'm just going to label the rest of the points. You can call them whatever you wanted, X, Y, Z, and L. I mean, it don't matter, okay? So I'm just going to do, because we know we're going to do them in those quarter turns, right? Oh, perfect. Okay? So I'm going to call that one C. I'm going to call this one D. I'm going to call this one E. And then I'm going to come back to B. Okay? So I got C, D, E, and then back to B. Okay? So I want to talk about the time. All right? I want to talk about the time. Every rotation, how's the time going to change? By a 5th. It's going to change positively, right? And so if I go from 0, it takes 1/5 of a second, right, to make 1 full rotation. So I should be at 0.2 when I get right there. Okay, so to do a full rotation, I got to go from 0 to 0.2, and I should land back up there at the top at 26. Okay. Now, you can put your points together any way you want, all right, in terms of what we're going to do, all right. But let's just think about what those values are going to be to get me there. Okay. What would be halfway between 0 and 0.2? 0.1. Okay, because we're doing them in halves. What would be halfway between 0 and 0.1? 0.05. Okay. And what would be halfway between 0.1 and 0.2? 0.15. Okay, so we're doing our halves. That's how I'm going to get my x coordinates. All right. Now, let's talk about our y coordinates. All right, let's talk about our y coordinates. And so if we're looking at, when I go from point B to point C, how much of that total height of 26 do I lose? 6, so I go to 20. Okay. When I go to point D, how much more do I lose from the 20? 6, which would give it 14. Then I'm going to start to gain some height. So when I get over here to point E, what is that going to give me? 20, and then I should land back at 26. Okay? So I write those points based on what the picture tells me before I assign them to the graph. Okay? That's what I do. All right? I think about what the motion would be. I think about my time. I got to go from here back to here in 0.2 seconds. And then I think about what would be halfway. And what's half of the half and half of the next half. Okay? It's all about halves. All right? So now let's talk about where the points could be. Which of those points could correspond to what we see on the graph? Okay? Is point B the tallest point on the graph? Because that's what point F is. It is the tallest point on the graph. Is it? Great. Okay? So then F is going to be the same thing as my point B. All right? So we're going to label F is going to be 0, 26. G should be at the midline. Okay? G should be at the midline. All right? Which would be that middle value. And is that what my second point was? Yep. So that's going to give me 0.05 and 20, okay? Then J is going to be this lowest point or the shortest Y value, so 0.114. So we had labeled these exactly like they appeared on the graph, okay? So 0.15 and 20, and then P 0.2 and 26. Okay, so again, 2 points. You get 1 for every x and 1 for all the y's. All right, being correct. All right, so that's A. Did I flip those? I did. I was like, wait a minute, I flipped those parts because that's C up at the top. We're going to jump down and do B. Okay? We're going to jump down and do B because that's the next thing that happens. Okay? So come down here. All right, I flipped the order. All right. It wants me to write an equation. Okay? It wants me to write an equation. Right? So we need an A, we need a B, we need a C, and we need a D. And I do it like that because I know now that A and D go together. All right? A is my amplitude, D is my midline. So if we go back and we look over here at these points, all right? If I go 26 and the midline is here at 20, what's my amplitude? It's 6, okay? So we can get that just from looking at it. So A is going to be 6. D is my midline. Well, that is that Y value right there. What is my midline? 20. Okay, so those go together and they get me a point. Okay, so amplitude, midline. This is why getting the points right is so important. Okay, now then we get to B and C. Okay, B is the period. Okay, or the number that's associated with the period. Because this is a trig graph, what is the typical period we see? It's 2 pi. But to get B, I have to divide it by how long it took me to make a full rotation, okay? Now, it took me 1/5 of a second, right? Or 0.2. I'm just going to say 1/5. That's a little bit easier for me, okay? How would I simplify 2 pi divided by 1/5? Add, flip it, and multiply. And what's 2 pi times 5 over 1? 10 pi. Okay, so B would be 10 pi. B is 10 pi. All right. Because we're using a sine graph, all right, it is that distance between the first and second point is always C, the x values, all right? How far is it from 0 to 0.05? 0.05, okay? So C is 0.05. It's just knowing how to find what you need, okay? This is always the distance between your x values of your first 2 points. Okay, just to help you find it, okay? So take 2 pi and divide it by whatever it was, that rotation, like when we simplified it for 1, that will always give you B. All right, 2 pi divided by whatever we did, okay, will give us B. All right? So that's worth 2 points as well.
We're gonna redo my calculator next year and take all the batteries out. And zip off. Huh? Zip perfect. Yeah, it works the same way.
Okay, so does that information, does that clarification help a little bit? Okay, I think we can get these points. We just need to talk about them. All right, we just need to talk about them. All right, now look back up at that top one. Okay, this is where it asks you to describe what's happening. Okay, so it's multiple choice. All right, you can simply just write A, B, C, or D. All right, or if they're listed, were they listed in the answer booklet or no? No, you can just put A. You can just put B. You don't have to write the words if you don't want to, okay? So that's nice as well. You'll still get the point as long as you say which multiple choice one you selected, okay? So it says between T1 and T2. So they say that goes between K and P. So let's go back and look, okay? So between K and P, all right, the K value is 20. The P value is 26. So what are we doing in terms of the graph itself? It's positive and it's increasing, okay? So we would choose option A for that one. Did you change your answer? Do not second guess yourself, okay? Yeah, don't second guess because 9 times out of 10 your gut instinct is correct, okay? It's always good to go back and look, all right? Look at your work. Make sure you didn't make a silly mistake, all right? But things like that, gut instinct. Okay. All right. Then the last one, describe how the rate of change is changing. What are we looking for on that? Concavity. Okay. We're looking for our concavity. And so if we look, what kind of concavity does it have? It's down. Okay. So that means the rate of change is decreasing. So we would say the rate of change what function are we doing? Of H is decreasing. And you want to say on that interval, so on T1, T2, because just don't say it, okay? Say because the graph of H is concave down. All right? They're super picky about that. So they call them naked answers. If you just put an answer down, the only place where you can leave it naked is A. is in part one of that one, okay? Of part C, because it's multiple choice within a free response, which I find interesting that they chose to do it that way, but I look for that over the next few years to change, if I'm just completely honest, but we're gonna take what they'll give us right now, right? Okay. All right. So then we get into just knowing all of our algebraic properties, all right? We do this function manipulation. Again, it's non-calculator, all right? So for part one, it says to rewrite g of x as a single logarithm without negative exponents. That's important, okay? Your results should be of the form, they're very explicit right here, ln times something, ln of something, okay? So let's take a look at this one, all right? Looking just at g of x, what do we know we can do with those coefficients up in front? Yep, bring them up as exponents. So I have the natural log of x cubed minus the natural log of x to the 1/2, okay? What else could we do? We could divide them, right? We keep our 1 ln and we divide, right? Could I simplify that some more? Yes, okay? We could use our exponent properties and simplify x to the 3rd over x to the 1/2. And so g of x would equal the natural log. 3 minus 1/2, again, you got no calculator here. Right, we subtract your exponents, 3 minus 1/2.
Wait, can you say that again?
Yep, 3 minus 1/2. 2.5, which would be 5 over 2. Okay, you could even put 2.5 up there. They would take it. Okay, yeah, they would take it. You just have to know to simplify. All right, get you a point. All right, 1 of 6. All right, we'll take every point they'll give us. Okay, because there are parts that are very difficult. Like that part C of question 2, that was brutal. Yes, sir.
So do you have to write all those, or do you just do one?
You have to show everything. Okay, yeah, you got to show your steps, okay? No naked answer. They call it a naked answer. All right, they call it a naked answer. So you got to show your thinking. All right. They probably let you go from 1 to 3. Okay, they probably let you do that, but not just put an answer. Okay, they won't take it. Oh, let me go back. All right, let's look at part 2. Okay, part 2, we get into those trig expressions. Okay, and they will be very specific. Rewrite it as an expression in which cosine appears once and no other trig functions are involved. All right, you should only have a cosine of something left when we're done. Okay, you might have a 1 on top, but you're not going to have a sine, you're not going to have a tangent, you're not going to have a secant. All right, they want you to leave it with a cosine. So let's look. H of x is equal to sine squared of x minus 1 over cosine. Well, if there's a cosine in the bottom, I'm leaving that bad boy because they want a cosine. Okay, think for a second, what could we possibly do with that sine squared x minus 1? What does it look similar to? Yep, it looks similar to our Pythagorean, right? Sine squared plus cosine squared is equal to 1. Okay, so be careful right here. If I wanted to get sine squared minus 1, what would I need to move out of this Pythagorean identity? How would I fix it? I'd switch it, right? I need the 1 to go over here and the cosine squared to go over there. And that's all legal. It's equal. We know it's true. All right, so I get sine squared minus 1 would equal a negative cosine squared. So I'm going to take that entire top part out. Okay, h of x is going to equal negative cosine squared. And we're going to divide it by cosine. Okay, so if I got a cosine squared on the top and a cosine on the bottom, what do I really have? I have just a negative cosine on the top. Okay, what do you want to think is the mistake that was most common on this one? They didn't finish. There are actually 2. That one, they didn't finish it because they said 1 cosine function. They didn't put the negative. Okay, Common mistake. You're excited because you see a sign squared and a 1 and you think, oh, that's squared, right? And you just throw it down, right? Because you're excited and you're tired. You've been doing math for a long time, all right? So it's just little things like that, okay? All right, let's look at the next two. All right. Okay. So again, two more functions they want us to mess with, all right? J of x is 2 sine x cosine minus cosine, and k is an exponential, okay? So 8, are you out of tape? Or did you get all you needed?
Yeah, I'm
Okay.
doing all my calculations.
Atta girl.
So it's all brand new next year.
Yay! All right, so then we want to solve j of x on the interval from 0 to pi over 2, okay? That means I don't need any plus or minus and pi's and k's and any of that mess, okay? Because they told me where to solve it. It's our trig function, and we want to solve it. So I have got, 2 sine x cosine x minus cosine x, and they want me to solve it equal to 0. Okay? So on this trig equation, what might be a good thing to do first? Okay, well, I can't really get rid of them, but I can factor them out. Okay, so there's a cosine in each one, so let's factor it out. So I get cosine equals 2 sine minus 1. If I have a product there, I can use zero product property, which is nice. So if I can factor it, then I'm one step closer. Okay, so I have cosine of x is equal to 0, and then that would give me sine of x is equal to 1/2. Okay. Now, we're going to go back to our unit circle, but here's the beautiful thing. It only wants me to solve it from 0 to pi over 2. So anything outside of that first quadrant or that 0 and pi over 2, I don't have to consider. Okay? Where in that little section is cosine equal to 0? At pi over 2. Okay? And where is the sine equal to positive 1/2? Pi over 6. Okay? And those were my two solutions. It always makes sense when I'm talking, right? What y'all have to imagine is I'm sitting over you asking you all the right questions. What would Ms. Moore ask me to do right now? Okay. So if it gives you a domain, finite answers. All right, that's the clue. All of my answers are going to be right there. If it doesn't, that's when we got to put that plus or minus mess on it. Okay, let's look at the next one. All right, I bet it wants me to do something with that other function that I haven't touched yet. Okay, so it wants me to solve k of x equal to 3e for values of x in the domain of k. Okay, so I'm going to take k, because I'm feeling lucky, 8e to the 3x minus e, and I'm going to set it equal to 3e. Fun. Okay. Fun. Okay. I don't know. Let's just see what happens. Okay. My e's don't match, right? So I don't think factoring is going to help there. Let's move that plain e over to the other side where there's another plain e. All right. The worst thing that can happen is you get a bigger mess. You can erase and start over. Okay. I mean, that's really the worst thing that can happen. So if I pull that over, that gives me 8e to the 3x would be 4e's. Okay, that looks a little better. All right. Let's get rid of the coefficient. Let's divide by the 4 so that we don't get a fraction. Okay. So that gives me 2e to the 3x equals an e. Okay. I guess it wouldn't have mattered because I need to move that 2 over anyway. All right, so let's take e to the 3x. It wouldn't have mattered. Equals 1/2 e. Okay, or the e over 2. Don't matter. All right, so I got an e on each side. All right, what's the only way to get rid of an e? ln. Let's take the natural log of both sides. So I'm going to take the ln of e to the 3x and the ln of e over 2. Okay, or 1/2 e. All right. What's going to happen over here on the left-hand side? What could I do with that 3x? I could move it to the front. And how much is the natural log of e? It's just 1. So I get 3x equals the natural log of e over 2. Okay. Can't separate that 1/2 e because it's not a exponent, right? It's already inside of there. Okay. And then what would I do to get x by itself? Yeah, divide by 3. So I can say x is equal to 1/3 the natural log of e over 2, and that is an exact answer. Okay, now, the only other thing they might want you to do there, by us having this division here, what does that really mean? Okay, it means we could separate it like that. And what do we know that ln of e is equal to? 1. So it could be the same thing as 1/3 times 1 minus the natural log of 2. I don't know that you had to do that. Let me look. I don't think you had to, but okay. It's not specific in the solution guide. All right. I think you're good at that first check mark. Okay. So again, symbolic manipulation. All right. When we get to part C, it is almost always a trig function on steroids, all right, and one that needs a plus or minus pi k of some kind, okay, almost always, all right. It was yesterday, all right, and we're going to do the one from last year in just a second and see if it held true, okay. All right, so let's take a look. So now it gives me this new function, okay. So m of x is equal to cosine of 2x plus 4. We want to find all input values in the domain of m that yield an output value of 9 over 2. In other words, solve for x. Okay, they just want to use big words. Okay, solve for x. All right, that's what it means. So we're going to take cosine of 2x and then plus 4, set it equal to 9 over 2. Okay. All right, well, that doesn't seem too terrible. Because there's just one trig function, if I can get that trig function alone, then maybe I can use my unit circle. So let's subtract 4. Okay, now 9 halves minus 4. How many halves would 4 be? 8. So 9 minus 8 would give me how many halves? Just 1. So it's just 1/2, okay? And at this point, I'm going to go to my unit circle. All right, I've got something other than just x inside there, but it's okay. All right, cosine is positive in the first quadrant and the fourth quadrant. Okay, which family gives me a cosine of 1/2? The pi over 3. Okay, so in the first quadrant, it would be pi over 3. In the fourth quadrant, it would be what? 5 pi over 3. Okay, 5 pi over 3. Okay. So in order for me to get a solution of pi over 3, to get back to that, I'd have to go a full 2 pi. Okay, so my first solution we know is going to be pi over 3 plus or minus 2 pi k. All right, but the problem is I don't have just an x inside of that cosine. What do I have? A 2x. So I have to say 2x is going to equal that. Okay. The second solution I would have, that same 2x, would equal 5 pi over 3 plus or minus 2 pi k. Okay, because I have to go all the way around the circle to get back. Now we solve for x. Bless you. To solve for x, we need to divide everything by 2. Okay, everything. So x is going to equal pi over 3 divided by 2 would actually be pi over 6. 2 pi divided by 2 would actually be what? Pi. Yeah, just a plain pi. Okay. For the next one, same thing. I'd get x. 5 pi over 3 divided by 2 would be 5 pi over 6. 2 pi divided by 2 would be pi. Okay. Now, what do we have to say is true about k? It's just an integer. It can be negative. Okay, because we could go both ways around the circle and get to those values. Okay, so we have to say k is an integer. All right, let's do the 24 questions. Okay, the 2024 questions. So that's what's next. So that's the problems are going to look like that. Again, variety of equations they could ask you about. But you can count on there's going to be a trig one where you're going to have a weird angle and you got to do the plus or minus mess. Okay, so just pay attention. A lot of you on the one yesterday, the first one, I believe, maybe it was, I can't remember. Anyway, one of the parts, you solved it, but it was on an open domain, so you forgot the plus or minus k stuff. Okay, that's okay. Now we're aware again. All right, we're going to get those points the next time. I have full faith. All right, not that. All right, let's look at the next one. All right, we're rolling a tire. So this was the actual question from okay. So the tire of a car has a radius of 9 inches, and a person rolls the tire forward at a constant rate on level ground, as shown on the figure. Point W on the edge of the tire touches the ground at t equals 1/2. So W is on the ground. I'm just going to think about this tire. I'm going to draw it. Okay, so my tire is on the ground. All right, so that's W. At t equals 1/2, what would its height be? 0. Okay, so I know that about W. When it's on the ground, it's 1/2. The next time it touches the ground is at 5/2. Okay, so if we think about our 5 points, W, X, Y, Z, come back to A. Okay, when I get back to A, I'm going to be at 5/2 and 0. Okay, so everybody with me? Right, so they told me that's how long it took me to get there. All right, okay. So let's see if we can fill in all the points. We know that, let's see, the maximum height of W above the ground is 18 inches. Okay, so when is that going to happen? At which of the points I labeled? Okay, if I go W up here at the top would be my tallest point, right? So that's halfway, all right? What does that mean the middle way heights have to be? 9. Okay, so the middle way heights have to be 9. All right, so question. How far is it from 1/2 to 5/2? 2. All right, it's 2. And what's halfway between? Yep, 3/2. Okay, it would be 3/2. All right, so sometimes I just like to think about my number line. All right, I got 0.5, 1, and I got 1.5. All right, so what would be halfway between 0.5 and 1.5? 1, and halfway between 1.5 and 2.5? 2. Okay, so there are my points. All right, everybody with me so far? Okay, now, so that's what it looks like based on what they told me. Now, here's the problem. Okay, W is not the highest point, is it? So we're going to have to continue this trend of rolling this tire. Where does my highest point occur in the points that I wrote? At Y. Okay, so this first point is going to be 3/2 and 18. All right, what's the next point going to be? 2, 9. What's the next point going to be? 5/2, 0. Now, the next points I don't have, but I can get them. Okay? So, between 2.5 and 3.5, what would be the next X value? 3, and my height would be back at 9. Okay, and then between 3 and 4 would give me 4.5, or what, 9/2? And I'm back at 18. Okay. No, it'd be 7, wouldn't it? Yeah. Sorry. Be 3.5, 7/2. Okay. So do you understand where, because I couldn't just use the 0, because 0 would mean F is sitting on the ground, would be the lowest point. And I can't go backwards in time, okay, because we're talking about time. So I have to have positive numbers, all right? We good with those points? All right, so there's my 5 points, okay? 1 for the X's, 1 for the Y's, all right? Now, let's write the equation. All right, let's get the equation. All right, the A and the D are going to go together. The B and the C are going to go together. Okay. Looking at it, how far is it, A is amplitude, from the middle to the top? 9. Okay. D is my midline. Okay, D is my midline. It will be 9. Okay, now, okay, it'd be 9. All right. Now, let's think for a second about B and C. B I can get, okay? How far is it from 5/2 to from 7/2 to 3/2, from where I start to where I finished? It's 4/2, which is just 2, okay? It's just 2. So to get B, we're going to take 2 pi and divide it by that distance. So what's my B? Pi. Okay. Now, C is the part where it's a little tricky. Okay, C is the part where it's a little tricky on this one. Typically, we can just do the distance between 3/2 and 2, we would say is what? We'd say it's 0.5, right? We'd say it's 0.5. But what makes this one hard is because we're kind of we're not at the first 2 points, right? We've moved it, okay? We moved it ahead how much? From 1/2 to 3/2, I moved it a full 1, okay? And because I moved it a full 1, if I actually go right, if I put it in an equation, what would I say? -1, okay? So you got to think about the original start to where we moved it, okay? If we start at the 0 point, the first point we have, then it's just the distance between the first 2. Okay, but if I have to move it, it's how far did I move it? Okay, how far did I go forward? I went forward a whole 1 second because I went from 1/2 to 3/2. Okay, and because I went forward, I say it's negative, which is bizarre. Okay. All right, so then we get to the next part. It's not as difficult. From K to P. All right, what do we have there? Are the Y values positive? Yep. Is it increasing or decreasing? It's increasing, so we choose A. Okay. What about the rate of change? It's decreasing on T1, T2 because H is concave down on that interval. Okay. If I had any to practice, these would be the ones I practice. Okay? I'd practice this third one because I think you can get more points on it than you think. Okay? That's the one I'd practice. All right, last one. All right, our symbolic manipulation. Okay, our symbolic manipulation. All right, so G and H are given. All right, the first one, we want to solve g of x equal to 10. All right, and then the second one, h equal to pi over 4. I'm going to run out of space, so I'm going to add a page and do it on the next page, okay? All right, so, for part A, first part, all right, I want to take e to the x plus 3. I want to set it equal to 10, right? What is the easiest way to do this one? I can't rewrite 10, but I got to get rid of that e. What should I use? Log. What kind of log? ln. There you go. Natural log, all right, of e to the x plus 3 equals the natural log of 10, all right? What's going to happen with that ln and that e? They cancel out. I get x plus 3 equals the natural log of 10. How do I get x by itself? Subtract 3. Negative 3 plus the natural log of 10. That's it. Okay, negative 3 plus the natural log of 10. You can't subtract the 3 from the 10. It's protected by the natural log. Okay, it's in the natural log jail. Okay, that would be the jail I would go to. All right, part 2 of A says that we want to take that trig function, arc sine of x over 2, and we want to solve it for pi over 4. Okay, arc sine is the same thing as what? Inverse sine of x over 2. Okay. How can I undo an inverse sine? We could, or we could just take the sine. Sine will undo it. Okay, sine will undo an inverse sine. So I'm going to take the sine of both sides. And the sine of pi over 4. So that's going to leave me x over 2 equals, what is the sine at pi over 4? Okay, and then if I wanted to get x by itself, what would I need to do? Multiply by 2, so x would equal the square root of 2, okay? Y'all tried to make that one super complicated, all right, on the one that was on your practice yesterday, okay? We don't have to. If it's inverse cosine, takes the cosine of both sides, okay? It will undo it, and we're good to go. Right. Know in your algebra what that one's about. Okay. All right, so let's look at the next part. Okay, part B. I'm going to go back so we can see the question. Okay, part B gives us, don't do that. Okay, part B gives us a crazy log function and a crazy trig function, all right? Part 1 says to rewrite it as a single logarithm base 10, no negative exponents, so our final answer should be log 10 of one thing, okay? All right, and then the second part, we're going to write it as a single term that has only tangent. Good to know. All right, let's switch over here. So for B, part 1, okay? It wants me to rewrite that function, which was j of x equals log base 10 of 8x to the 5th plus log base 10, 2x squared, minus 9 log base 10 of x. Okay, here we go. Well, the first thing I notice is I could pull that 9 up as an exponent. I've got addition and I've got subtraction. What I'm going to do with the ones that are being added, I'm going to multiply them, so it's going to give me 8x to the 5th times 2x squared. And then what am I going to do with the one that's minus? Divide, and it would be x to the 9th. So you could do all that in one step. Okay. We got to get it to a single log, so let's simplify. On the top, that's going to give me 16 x to what power? 7th over x to the 9th, right? So let's simplify those powers. I'm going to keep the 16, okay? Remember, when you're dividing, you subtract exponents, but put your answer where the big one is, okay? So what's 9 minus 7? 2. So we can put the x squared on the bottom. That would be my final answer. Okay. All right. Part 2 on B is that trig thing. Right. So part 2 says it wants me to write it as a single function of tan. So I have 1 minus sine squared over sine times secant. Okay. Looks like I got a lot of work to do. All right. Because to get a tan, what am I going to need? A sine over a cosine. Okay, I'm going to need a sine over a cosine. So I got some sines right there, but let's start by messing with it a little bit. 1 minus sine squared, what does that look a lot like? Our trig identity, right? Sine squared plus cosine squared equals 1. Okay, so if I got the sine squared over there with the 1, what would it leave me with? Just a cosine squared. So I get a cosine squared over a sine. And how do I do secant? 1 over cosine. Okay, so I'm multiplying two fractions there. Okay, multiplying two fractions. Am I going to be able to reduce something? The cosine. I have one cosine and 2 on the top. It will leave me with just 1 cosine over sine. Well, that's really close to what I want. That's actually what? Cotangent, but I want tangent. So to get tangent, it is just you could even say this. This is cotangent, which is 1 over tangent. And that's what they were looking for. Okay, so we simplify it. We do get that cotangent, but we wanted 1 over tangent. And then part C was tough, okay? Again, it was one of those where I think our average was like maybe 0.9, and the national average the global was like 0.3 points, okay? I mean, it was rough on this last part, okay? It was hard, and they're going to put stuff on there that's going to be like that, okay? They have to. It's like it's a rule, okay? All right, let's look at this last piece, okay? So this time they give you m of x equals inverse cosine of tangent of 2x. Where does that equal 0? Okay. All right. Well, let's just play around and see what happens. Okay. I'm going to jump down here to the bottom. So for part C, thank goodness it's just one question, and there's a reason why. So we want to know, where does cosine inverse of the tangent of 2x equal 0? Okay. Well, just like we did the last time, I want to get rid of that inverse cosine. And what's the quickest and easiest way to do it? Take the cosine of both sides. Okay? So we're going to take the cosine of that whole bloody thing. All right? Which is going to leave me with just tangent of 2x equals the cosine at 0. All right? That looks a lot nicer. Okay? What is the cosine at 0? It's 1. Okay? Now I can go to my unit circle. I have one trig function. Where is tangent 1? Where would tangent be positive? First and third, because you got a positive, positive, and a negative, negative quadrant. Tangent's y over x, which family gives me the same x and y coordinates so that I get 1. Pi over 4. Okay, so I get pi over 4, right? And then what would this one be? 5 pi over 4. Okay, now, So we have a tangent in there. It's 2x. So we're going to keep 2x equals, let's start with that first one, pi over 4. How far would I have to go to get to the next solution? Just a distance of pi. So plus or minus pi k. And that takes care of my second solution. So I'm only going to have to write one thing down. Okay? They will not count it wrong as long as you do the math correct. If you also said 2x equals 5 pi over 4 plus or minus pi k. Okay? Which would be legal. All right? But you really don't have to. If they're pi apart, just write the first solution down with the pi. Okay? On that last one we did, they were not pi apart. So we had to use the 2 pi. Okay? Just like we did a few minutes ago, let's divide everything by 2. And so x would equal pi over 8 plus or minus pi divided by 2. So I'll leave it pi over 2k. And we would say k is an integer. All right, so I gave you, and I would recommend that you spend some time looking at these this weekend, a packet that has like 4 examples for each question. So think about the questions you know, I am not good at this question. Work on those, okay? Work on those. You don't have to do all of them, you know, or maybe sit down and the answer keys are online, okay? Do a little bit, all right? I'm not asking you to study for hours on end, but you do need to do a little preparation, okay? Do a little, okay? Do a little. I'm going to give you this back from yesterday, okay? Remember, for your exam grade, it's leveled, right? So if it's a 5, it's a 95, 4 is an 85, 3 is a 75, 2 is a 65, okay? And so I may offer, like next week, if you wanted to do another practice test, okay? I might offer that if you want to, but it's 3 hours. It'll take you 2 days to do it. Okay, and it'll be a full working, all right? I'll give you that option if you've not done one, okay? So let me give these to you so you know. Again, I take the highest of all the ones we do, and that's what I put in for your exam. Everybody in here has to have an exam grade, all right? So my foot's asleep. Y'all gonna have to come get these. Okay, Jace, Caleb, Elise, sorry. Like, I literally cannot stand up. I'm gonna fall over.
Well, you got it too.
Okay. Sam, Isaac,
You do that too.
Carly, Hallie, Lucy. Madison, Wilmer. Landon, JJ's not here, Gavin, and Roger. Oh,
That was,
Last time I got it.
I thought it didn't work.
okay. Hang on to this. Monday, we're going to go over it. Okay, we're going to talk about it on Monday.